Math 8, Volume of Spheres. This is the main lesson video. I can determine the volume or radius of a sphere. First, you should understand what a sphere is. A sphere is the set of all points in space, three-dimensional, that are the same distance from a point called the center. The radius r is the distance from the center to any point on the sphere. And there are a lot of things that are spherical, like basketballs, baseballs, the earth, the sun, a lot of spherical things. It's very common solid. Now we're going to derive the formula for the volume of a sphere with the following idea. If you were to take a little surface region of the sphere and cut clear to the center of the sphere, you would pull out what's pretty closely approximated by a pyramid. It's not perfectly a pyramid because this side right here is not flat. It's a little curvy because it's part of a sphere's surface, and the surface of a sphere is not flat. So what we would do with this, the area of that base, we're just going to call it B1. B1 just being one section, one of the base's areas. And then each of these pyramids is 1/3 B1 times R, R being the height or radius of the sphere, so it's the height of each of these pyramids. So the volume of this sphere is going to be volume 1 for this first one, plus volume 2 for this one, and volume 3 and volume 4 and volume 5. And somewhere over here on the back side you might have a volume 263. Anyway, there's going to be a bunch of these added together. It doesn't really matter how many there are all together, but the volume is just going to be replacing those volumes with the formulas. 1/3 the first base times the radius, 1/3 the second base times the radius, all the way to the nth one, which would be the last one. By the time you get there, you've included every single pyramid piece that you could cut out of a sphere. Kind of like cutting a pie into pieces or a pizza into pieces, except this is three-dimensional and not flat. So just applying a little bit of 6th and 7th grade math dealing with the distributive property. Each of these terms has 1/3 and r in it. So we factor those out, which is using the distributive property in reverse. We get 1/3 r. And all of these base areas end up getting added together. Well, all of these base areas together make up the entire surface of the sphere. So that would be the entire surface area of that sphere. Okay, S is the entire surface area of the sphere. Now there is a formula for that. We're not going to go into why this is what it is, but it is 4 pi r squared. There are some interesting videos on YouTube that talk about why it is that way. Why is the shadow of a sphere? Why is the surface area of a sphere 4 times the area of its shadow? Anyway, plugging that in, you get 1/3 of r times 4 pi r squared. And simplifying that down a little further, you get this, the official formula, 4/3 pi r cubed. And at the end of the video, we're actually going to see another interesting relationship with the sphere as it compares to the cone and the cylinder. So back to the introduction. So we talked about what a sphere was. Now the volume V of a sphere is the product of 4/3 of pi and the cube of the radius of the sphere. So it is 4/3 pi r cubed. All right, let's go through our first example. We're going through the same steps that we did for the cone and the cylinder. You can look at those videos if you're unfamiliar with them. Since this is a sphere, I'm going to start out, first step, writing the formula that is used to find the volume of a sphere. The nice thing about the volume of a sphere formula, there are only 2 variables, V and R. In this case, we know R is 4, so we're going to plug in 4 for R. So going to my calculator, just typing in 4/3 pi times 4 to the 3rd power. If you don't know how to do 4 to the 3rd power on your calculator, it could be typed in 4/3 pi times 4 times 4 times 4, because times 4 times 4 times 4 means the same thing as 4 to the cubed, 4 to the 3rd power. And this comes out to give us a volume of 268.08, which I'll just round to 1 centimeters cubed. And that's it. Let's go to the next example where I believe the volume is missing. No, the volume is given. The radius is missing. So notice that it is a sphere. Since it is a sphere, you're going to put in for the formula, v equals 4/3 pi r cubed. Identify the volume as 288 pi. Now, interesting thing here, this number has not been approximated with a rational approximation. It's given the exact 288 pi, which will actually lead to a little bit of help for us as we solve. So, plugging in the volume, 288 pi, first thing I notice is there's a pi on both sides, and getting rid of that's a good place to start. And this is 288 equals 4/3 r cubed. Now I can divide by 4/3, but remember when you divide by 4/3, it is logically equivalent to multiplying by 3/4, because when you divide by a fraction, you multiply by the reciprocal. The reciprocal of 4/3 is 3/4, so I get 3/4 times 288, and that is 216, and that equals r cubed. Now, depending on what calculator you have available to you is how you will be able to cube root this. If you are on a cell phone, you would need to turn the phone sideways so you can get the extra scientific functions to be able to do the cube root. On the calculators we use in the classroom, you type in the 3 and then you do the cube root function, which is doing the second, and then the key you press if you want to go to a power other than 2, the caret key, and then you type in 216. By the way, what that looks like on the TI-30 calculator, you'd press the 3 and then you'd press the second button, and then you'd press that little caret key, and then you type in your 216. On the display it looks like this: 3/3 root of 216, and you press equals, and it should come out to be 6. Oh, it is 6. So the radius of this ends up being 6 inches. The reason I know it's inches is because the volume was given in cubic inches. Okay, next examples. Find the volume or radius of the sphere, round to the nearest tenth if necessary. Okay, on this number 1, first thing I do is I notice it's a sphere, so I write down v equals 4/3 pi r cubed. I recognize that the radius is, well, the number is not given here, but since radius is halfway apart across and it's 16 all the way across, this would have to be 8. So this is 4/3 pi 8 to the 3rd power. 4/3 times pi 8 to the 3rd power. And that is 2,144.66, which will round to 0.7, and this is feet cubed. Okay, next, number 2 here. The first thing you would do is recognize this is a sphere, giving you the need to write the formula, v equals 4/3 pi r cubed. V is given as 36 pi. R is unknown. So we will rewrite 36 pi in for V, and then 4/3 pi r cubed. And let's see, what do we got here? There's a pi on both sides, so let's get rid of that. This is 36 equals 4/3 r cubed. Let's multiply by 3/4 on both sides. That gets rid of that. And r cubed therefore equals, I believe this is 27, but I'm going to double check by doing the calculations. Yes, I got 27. And then you'll cube root that, which this comes out to be the really nice number 3. So the radius here is 3 meters. Alright, there's one last thing I wanted to mention here, and this is a really interesting thing about cones spheres, and cylinders. First off, the cylinder, well, let's write the V in there, is pi r squared h. And the cone is 1/3 pi r squared h. So the cone fills up 1/3 of the cylinder, and of course the cylinder fills up all of the cylinder. The sphere actually fills up an interesting fraction of the cylinder. And that fraction ends up being 2/3. And I'm just going to demonstrate that that is the case. The volume of this would be 2/3 pi r squared h. But h, in this case, from the top to the bottom of this, it is 2 radiuses, or 2 radii, I guess is the actual plural there. So h I'm going to replace with 2 radii, or 2r. Now, doing a little bit of simplifying here, the parentheses are not necessary because of the associative property of multiplication. So I've got 2/3 times 2 is 4/3. Pi is, of course, there. R times r, well, actually that's r squared times r is r cubed. And there is our volume formula for a sphere. So if on the test you kind of forget some of these formulas, if you can at least remember this formula, and you remember 1/3, 2/3, and 1, you would have all 3 of these. Because given the same dimensions, a cone's volume plus the sphere's volume equals the cylinder's volume. Very interesting relationship there. Thank you for watching.